So what you now have is your four frames for your animation. So you have frame 1, frame 2, frame 3 and frame 4. What we're going to do is we're going to change these a little bit. We don't want them as separate unsigned characters, so we're going to create a multi-dimensional array. I've just deleted the sizes of each frame because we don't need them, and we're going to change these, and we're going to call them, instead of frame 1, frame 2, frame 3 and frame 4, we're just going to call them icon because it's easier. However, this icon is going to be different in size. It is going to have 2 dimensions to it rather than 1 dimension. The first dimension will be called frames and the second dimension will be called size, bytes, and that will be the size of each frame in bytes. So before we can use that, we're also going to create 2 constant integer values, one called size bytes and the other one is going to be called frames. In our case, our size bytes is going to be equals to 376 and our frames will be equals to 4. So that's because we've got 4 frames in this animation, and each frame within the animation will be 376 bytes long. How do I know that? Well, I know that because if I count all of these things here, we have 376 of them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 31. So if you do 12 times 31 plus 1, 2, 3, 4, you get 376. So we now have our size bytes integer, we have our frames integer, they are that frames and size bytes there. We now need to make this into a multi-dimensional array, so we then delete this like that and we put a comma there, we delete that, put a comma there, delete this, put a comma there, and we leave that as it is. So as you can now see, this is just one big array called icon, multi-dimensional. So the first 376 bytes is that, the second 376 bytes is that, third 376 bytes is that, and the fourth 376 bytes is that. By putting it in a multi-dimensional array like that, it will make it easier for us to iterate through when we want to display it on screen. Now we can just check to make sure we've made no syntax errors just by clicking the compile button to verify our code, and we'll see what happens. Hopefully we'll get no errors. So yep, so that's done compiling. We've made no errors, so you have to remember that in between each of your frames you need a little comma there, and you can delete all the other stuff, so the declaration of the array can all be deleted, but you need a comma between each one. Then at the end of your array you need your curly bracket and your little semicolon. So we now have our animation frames in a format that we can use easily. So the next thing we need to do is to include the library, and as you know, the library that we are using for the purposes of today is the U8G2 library. The U8G2 library is a really good library. If you haven't got that library, you need to download it and import it into Arduino IDE. You can download it from the GitHub page, which is here. This is the GitHub page for the library. If you go to it there, you can download it from here. So you can download zip, then you can import that into Arduino IDE by going to include library, add zip library, and then selecting that. I've already got it imported here, so don't need to do that. But this is a library that we're going to use, so I have included that. I'm just going to verify. If you verify at this point and you get an error, it is more than likely because you haven't got that library included in your Arduino IDE. As I mentioned earlier, we are using a screen that has the SH1106 chipset on it. So now we need to create an object to represent that. And if you look in the examples for the U8G2 library, there's lots of constructors for different types of screens. The constructor that we're going to use in our case is for the SH1106. We're also going to use hardware I2C to connect it to the board as well. So I'm just going to write down the constructor. So the constructor that we'll use is this. So it's that. Then SH1106, because that is the chipset in our screen. And then you put the resolution down. In our case, it's going to be 128 by 64. It doesn't have a specific name or brand, so we then write no name. We write F there because that's the way we're rendering the frames to the screen. We're going to render a full frame to the screen. We're going to use hardware I2C, so we type in HW for hardware. We then say that we're going to use the I2C interface, so you've got the option of using the I2C interface or the SPI interface. And then we will give it a name, and in our case I'm just going to call it auxiliary screen, so aux screen for short. And then we have a little argument. Now this argument will tell us how the screen is rotated, so U8G2 underscore R0, that means no rotation. If you put R1, it rotates it by 90 degrees. If you put R2, rotate it by 180 degrees. R3 will then rotate it by 270, and R4 will do a full rotation, so we'll have an upside down screen, I think. So that's our constructor. Make sure we've made no typos by verifying the code. Boom, so that's it. So what we have now is we've included a library. We've created the object called aux screen that we're going to use. We've created a multi-dimensional array that represents each frame in our animation. So now we're going to go into our setup part of the code. What we want to do is type the name of the screen, which in our case is aux screen.begin. And that will initialize the screen when the microcontroller starts up. We might as well also initialize the serial interface just in case we need to use it for debugging purposes. So we'll also type in serial.begin 9600, which is the baud rate, and that's it. So the screen is now ready to be used. Above our setup function, we're going to create our own function, which is going to be called playAnimation. So it's going to be void playAnimation, and we'll leave it at that for now. So we're going to have a playAnimation function. So what we're going to do, so when we're playing the animation, we're going to have a few different things. We're going to play an animation, and we also want the animation to move across the screen depending on what animation we're playing. So we're going to have a look at what arguments we're going to have in our playAnimation function, and the first two arguments will be width, so the width of the animation, and the height of the animation. The reason why we're putting them in here is because we're going to expand on this function later, and we'll be able to play different animations with different images, so we need to define the width and the height. And then we're going to have something called frame delay. So our next argument will be frame delay. That'll be the time in milliseconds between playing each frame. So depending on your animation and how many frames you have, you might want different delays for different animations, so you have that as an option. And then we're going to have another integer value called X increment, then another integer value called Y increment, and they will be how far the animation will move per frame, so the increments in movement across the screen or up and down the screen. After that, we need our start and our end positions for both the X and the Y axis, so that'll be another integer, so integer start X pause and integer end X pause. We'll then have an integer start Y pause and an integer, just make this full screen, integer end X position. We also need to tell this function how many frames we have, so we'll have a function called int frames, and then we need to tell the function how many bytes each frame is, so an integer called size bytes, and then an unsigned char which will actually be the icon. We will compile this to make sure we've made no syntax errors. Boom, and we have made a syntax error. So redefinition of int end x pause. So I've typed in x pause there instead of y pause. There we go. Let's recompile that. So that's looking good. So what we have here, I'll write this. So we have so we have the width of each frame, we have the height of each frame, we have the frame delay, we have the X increment, the Y increments, that's how much the animation will move between each frames, then the start X position, end X position, start Y position, end Y position, then number of frames, and then the size of each frame, and the actual icon. So this might appear to be duplication of efforts because the icon, the size and the frames are all global variables, same with the height and the width. These are all here. Look, we've got an icon here, we've got the size, we've got the frames, and we've not got the height and the width, but we could have had the height and the width as a global variable. And the reason why I've put them in here, which may seem somewhat wasteful at this moment in time, is because later on in the video we will turn this into a class, and all these will need to be defined as part of the constructor for that class. So we're just saving time here by writing them down here, just to make later on a lot easier. So as you've noticed, the things that are global variables like frames, so we've got underscore frames here, and that's the same as frames up here. So to denote that this is a local version of that, I've just put an underscore in front of the definition, just so we know, same with icon and same with size bytes, so we know that that's a local version of that variable rather than the global version of the variable. Right, so now we have our play animation. So what's our play animation going to do? It's going to cycle through each frame in our animation. It's also going to move the animation depending on what the X and the Y positions are. And yeah, and that's all we're going to do. So the first thing we're going to do is we're going to create some local variables, one called X position, one called Y position. So int X pos and int Y pos. To start off with, the X position will be equals to the start X position, and the Y position will be equals to the start Y position. And these two variables, X pos and Y pos, is what we're going to use to keep track of the position of the animation on the screen. Next, we will create a boolean called toLoop. Boolean toLoop, and that will be equals to true when we start off. This boolean toLoop will tell the program whether or not to loop through the animation. So as long as this is true, the animation will be played. As soon as this turns to false, the animation will stop being played. We're then going to have another boolean called left to right, left to right, and that'll be equals to true, and another boolean called up to down, up to down, and I'll just change the case of the two. And that'll be equals to true. So on this, so with the left to right, I can't put an uppercase T because that's a built-in function of some sort, so we just call it left to right like that. And then what else do we need? We need to tell the program whether or not to increment the x-axis and whether or not to increment the y-axis. So we'll have another two booleans, one called x to loop, so x to loop, and one called y to loop, and they will both be equals to true. Remember when you're creating these variables that they are all case sensitive. So as I mentioned at the start of the video, this is going to be a blocking function, so while the animation is running, your code won't be able to do anything else. Now this isn't ideal, but we'll build upon this later and we'll create a non-blocking function, but for now we'll do the blocking function. So we'll create a while loop, and while the while loop is being executed, the animation will play, hence why it's blocking. So we'll create a while loop, so while toLoop is true, we will just go through this loop. So what do we want to do next? So we have our various things up here to tell us when we should be doing certain things and the state of what's going on. We have our X and our Y position, so we can track where the animation should be on the screen. So I'll tell you what we'll do. For now, we'll just draw the animation on screen. So we'll forget about the X and the Y stuff, and we'll just draw the animation and loop through the animation without it moving. So how do we do that? So we have this here. So we have a multidimensional array. We can't use this directly in the way that we'd want to use it. So what we're going to do is we're going to create a one-dimensional array that we can copy whatever part of this array into that array and then use that to display the image, if that makes any sense. So in order to do that, we're going to have to create a unsigned character array, and we'll call it TMP icon. So temp icon, I'll actually have a capital I reckon, temp icon, and it will be the size of the size bytes integer from here. So that should be 376 in our case. So now we have our temporary icon array. We need to create a for loop to add the array that we already have to this array. So that doesn't make much sense, does it? So we'll say for, we'll have for II equals 0, II is less than cool. So what we're doing there, saying we're going to loop through this for loop until II is the same size as size bytes, and every time we increment we're going to add 1 to II. So what we're going to do here is we're just going to do temp icon, the temp icon array is the frame that we display at any one time of the animation. So temp icon array is the current frame that we're displaying. So what we're doing here with this for loop is we're copying the current frame into the temp icon array. I'm messing around with the code here a little bit because I wasn't sure what format to use, because I'm writing this code on the fly, so that's why I'm messing about with it. But that's what the temp icon array is. It is the frame that we're going to display at any one time of the animation. And we need another loop here, so yeah, I just right, okay, so we need two loops. So let's create the two loops, and then once I've written them I'll explain why we need two loops. So for II equals 0, so what we have here is we've got two loops. We've got an inner loop and an outer loop. So the outer loop will iterate through each frame. So we'll go frame 1, frame 2, frame 3 and frame 4. And the inner loop will allocate each byte to the temp icon array 1 byte at a time. So for frame 1 will be iterated through. So we go through frame 1 and then we will copy icon, frame 1 in icon to temp icon, and that's pretty much what this is doing. So we've now done that. So the outer loop is iterating through each frame, and the inner loop is iterating through each byte within the image for each frame. So now we have temp icon now has values that it should have allocated to it. We can now draw the actual bitmap to the screen. Before we do that, I will verify the code to make sure we've made no syntax errors, because it's very easy to make errors in Arduino IDE, and guess what, we have made an error. So what's that saying? Unexpected primary expression before the close bracket token. Cool, I missed the extra pluses off there. So we compile, just make sure we've made no syntax errors at this point. Oh, and it's saying that we have made a error, so that's because we've not put a capital I there, so put capital I. And we'll delete that. Cool. Now what we're going to do, we're going to type in delay, and then we're going to use a frame delay. Delay frame delay. So we're going to wait whatever the frame delay is before we draw the next frame in the animation. So remember, frame delay is the delay between each frame. So all we need to do is literally to draw each frame. So auxiliary screen dot draw xbm, and then The X position, the Y position are the first two arguments that we're going to use. X position, Y position, the width of the animation, the height of the animation. Now these two variables, the width and the height, have to be correct. If they're not, your animation will be displayed incorrectly. And then the last argument will be the actual icon that we want to draw. So we've sent that data to the screen. So, or at least we've written that data to the to somewhere in memory. We then need to send it to the buffer, to the screen buffer. So we then go auxiliary screen dot send buffer. And that should be it. So what have we done there? So for now, if we just ignore all that, ignore all that stuff there, we've got a while loop. Within the while loop, we've got two for loops. We've got an outer for loop, which will iterate through each frame. So it will go from frame 0 to frame 3, which is 4 frames in total. Then we have an inner for loop, which will copy part of the multi-dimensional array to a temporary icon array. And then that temporary icon array is what we're going to use to draw the image on screen, and then we're going to delay the program by our frame delay, and then we're going to draw our bitmap onto the image, onto the screen, and then we're going to send it to the screen's buffer. So all we need to do now is to play the animation. So if in our for loop we type play animation, and then we put all these horrible arguments in. So in our case it would be play animation, 64 is the width, 47 is the height, and let's have a frame delay of 50 milliseconds for fun. X increment 0, Y increment can be 0 because we're not using them. Then X start, let's just say 10. No, let's say 10. So that's position 10 on the screen. If you want to know how the coordinates work with the this library, go onto the GitHub page, and there's an explanation there. Our Y coordinate, let's try 0 for a Y coordinate. So the amount of frames that we have, we'll just use the frames global variable. The size in bytes, we'll use the size bytes global variable. And then for the icon, we'll use the icon global variable. So let's then verify that, see if that will build. And hopefully it will. Oh, we've got an error. Always got errors. Right, so what's this error? Okay. I've missed some stuff out, haven't I? Right, so so height, width, height, frame delay, X and Y, X increment, Y increment, X start, X end, Y start, which will be 0, and Y end. Cool. There we go. Boom, done compiling. I'm going to upload that to my microcontroller, and we'll see what happens. So what we should have when it uploads to the microcontroller, we should have the animation should play, but it'll be stationary on the screen. It won't be moving on the screen as we may want it to. So uploading, we've uploaded to the screen, and this is what we have. Now that animation is all very well and good if you don't want it moving across the screen, left to right, right to left, up to down, down to up, or whatever. If you just want it to be stationary, you can leave it at this and have a blocking function that will draw an animation onto the screen. However, we're not happy with that. We want it to move across the screen. in order to make it look like it should look. So next we're going to change the function that we have written, the playAnimation function, and we're going to add some bits in it to make the bird move from left to right and up to down, or the opposite way round. So what we're going to do now is make the animation move from left to right or right to left, depending on what our start X and our end X position is. So let's have a go at this. Right, so within our main while loop here, within the playAnimation function, we'll go into the outer for loop, and we're going to have an if statement. We're going to say if our start X position minus end X position is less than 0. So what this if statement is doing is having a look. It's telling us whether we're going to move from right to left or left to right. So if our start X position is 0, for instance, and our end X position is 64, this if statement will evaluate to minus 64, so it will be less than 0. So if it's less than 0, we'll be moving from left to right. And then if it's not less than 0, we'll be moving from right to left. So what we're going to do here, so left to right. So if you remember, we had a boolean called left to right. So if this evaluates to true, we'll say left to right equals true. Otherwise, left to right will be equals to false. So we now know whether we're moving from left to right or right to left. There's something else we're going to have to look at here as well. So if we're moving from left to right, we want to know whether or not our X position is less than the end X position. If it is less, then we need to continue moving. If it's not less, then we need to stop moving because we've reached the end X position. So we have another if statement in here, and we're going to say X, if X position is less than end X position, X to loop will evaluate to true, else X2 loop will evaluate to false. So we have two things going on here. So we have detected the direction of movement, whether it's left to right or right to left. So left to right there, right to left there. We've also checked that if we're moving from left to right, whether we've gone beyond our upper bound. So if we've gone beyond the end X position, we're going to stop moving in the X axis. So we then need to do that check here. So we need to do if xpos is greater than end X position, and then we'll just copy this. Boom. So if X position is greater than end X position here, X2 loop will be true, and otherwise it will be false. So because when we're moving from left to right, we always want the X position to be less than the end X position, because we're going from left to right, and left will be 0, right will be 128, for instance. But then if we're moving from right to left, it's the opposite. So we always want the X position to be greater than the end X position. So for instance, the X position in this case could be 128, whereas the end X position could be 0. So here we have detected which direction we're moving on the X axis, and we've also checked our upper and lower bounds, so we know whether or not to stop moving in the X direction or to continue to move in the X direction. And they are, so that's checking, so we're constantly checking stuff there. And what we now need to do is the exact same but in the Y position. So what I'm going to do is I'm just going to verify the code to make sure I have made no syntax errors, which I haven't. So it says done compiling, so that is good. And then I am going to copy all of this. So I'm going to copy it. I'm going to make a few lines so it's obvious what I've copied. I'll copy and I'll paste it here. And all I'm going to do is change it from the X position to the Y position. So I'll change all the X's to Y's. So X to Y, change that to Y. So all the X's will be changed to Y. And right to left obviously isn't right to left, it's up to down instead. So right to left will be changed up to down, and I'll change the comments as well. So what do we have here? So we have if start Y position minus end Y position is less than 0. Up to down will then be true, so we're moving up to down. So we're moving from the top of the screen to the bottom of the screen, and then if it's not true, we'll be moving from bottom of the screen to top of the screen. And then everything else is pretty much the same as in the X direction, but in the Y direction. So yeah, so firstly we're checking whether we're moving up to down or down to up, so from top to bottom or bottom to top, and then we're checking to see if we've gone beyond the end Y position or whether, depending which direction we're moving. So if we're going from up to down, we then need to check Y position is less than end Y position, and if it is, we continue. If it's not, we stop, and vice versa for going from bottom to top. So we've checked our bounds and we've checked our direction here, but we've not actually moved the animation yet. We've just checked stuff. So we're just checking stuff here, and we've made lots of checks. It looks a little bit complicated. We've got some if statements and nested if statements. So now we need to use that information to actually increment the X and the Y position, which are down here. So what we're going to have after the delay, we will have an if statement, and it's basically going to say if X to loop equals true. And I'm just going to write another if statement because it may become obvious why we've got these kind of strange if statements. If Y to loop equals true. Okay, so you don't have to have the equal sign, you could just have that and it means the same thing, but I'm just putting the equal sign just to make it absolutely obvious what we're doing here. So what we're basically saying here is if we still need to move the animation in the X-axis, then we're going to do some stuff in here, and then once we've done that, if we still need to move the animation in the Y-axis, we're then going to do some stuff here. So the X and the Y-axis are independent from one another, so if you're only moving a little bit in the X-axis, you reach the end X position, but then you still continue to move in the Y axis as well. They're not mutually exclusive, they're independent from one another. That's why we have the two if statements here. So we've got that, so then we're going to say what we're going to say. So now we need to know whether to add the increment to the X position or to take away the increments from the X position. So now we're going to say if left to right equals true. So if we're moving from left to right, we're going to add something to the X position. So we say X position equals X position plus 1. Oh no, not plus 1, plus increments, plus X increment. Was that lowercase? Yeah, plus X increment. And then if that's not true, we're going to say else, and we're going to take it away. So we're going to do the same thing, but we're going to take away. So so if we're moving left to right, we will add the increment to the X position. If we're moving from right to left, we're going to take the increment from the X position, and this will only happen if we're looping on the X axis. Now we're going to do the exact same thing but for the Y axis. So I'm just going to copy that because everything's written down, and I'm going to change all the X's to Y's. Boom. So all the X's can be changed to Y's, and obviously left to right needs to be changed to up to down, up to down. Let's verify that code to make sure it's working correctly, and it's compiled. Whether it works or not, I don't know, but it's definitely compiled. Cool. So what have we done so far? So we've created a playAnimation function. Within that function we've set some initial variables that we're going to use later. We've then created a loop that will draw the animation, that will go through each frame in the animation and draw them independently. We then have a for loop which will iterate through our frames. We then detect which direction we're moving in the X plane, and we detect which direction we're moving in the Y plane. We also detect whether or not we've met the end X position coordinates and the Y end position coordinates. If we haven't met those end Y coordinates and the end X coordinates, we will then move the animation by either incrementing the X position or taking or decrementing the X position, and same with the Y position. We'll also copy the frame to a temporary character array, and then we'll draw that temporary character array onto the screen and then send it to the screen. So if we was to play this now, if we was to upload this onto the Arduino, it would work. However, this would loop indefinitely. So now we need an if statement to say, should we continue to loop? So what we're going to say is, we're going to say if, how can we do this? So if X to loop equals false, and Y to loop equals false, then to loop will equals false, to loop will equals false. Aha, so what have we done there? So we pretty much said that if we reach the end X position and if we reach the end Y position, to stop the while loop. So to loop will be equals to false. So we'll then break out of this while loop and then increment whatever is next within your main loop for your Arduino microcontroller. So I think that should be okay. So I'm now going to upload, no I'm not, I'm going to change something first, so I need to change this, don't I? So if I was to upload this to the Arduino, it would work, however the animation wouldn't move because we have these haven't been set yet. So what I'm going to do is to set them. So what I'm going to say is I'm going to say that the X increment I'm going to set to 6, so it will move. So between each pixel, no, between each frame within the animation we're going to move 6 pixels. Y increment I'm going to keep to 0 because we're just going to walk across the screen. I'm going to say that we're going to start at -64 X coordinates, so that's off the screen, and we're going to finish at 128. So we're going to start off the screen and we're going to walk off the screen. We're going to start on the left side of the screen, we're going to walk to the right side of the screen, and then with the y-axis we're going to keep them to 0 as well because we're not going to bother with y-axis at the moment. So I'm now going to upload this to the microcontroller and we'll see what happens. And we're now uploaded to the microcontroller and this is what we're getting. So what's going on there, I wonder? So it's walking across the screen like we wanted it to, but there's some artifacts that are being left. Now let's have a look at the code and see if we can get rid of those artifacts. So looking at the code, so what we're doing, so we're doing lots of stuff up here, yeah, don't care about that. We're doing this, so we're drawing the XBM and then we're sending it to the screen buffer. So what can we do to get rid of the artifacting? Aha. So let's have a look at here. See, so we've got clear and we've got clear buffer and clear display. We don't want to clear and we don't want to clear the display, because if we do that it will flash, which will look horrible if it's flashing. So let's have a look, see what clear buffer does. Clear buffer. So description: clears all pixel in the memory frame buffer. Use send buffer to transfer cleared frame buffer, blah blah blah. Right, this looks like, right, okay, so we're going to try using this. So we're going to say looks screen dot clear buffer. Ooh, too many furs. Clear buffer. Okay, so we're going to clear the buffer between drawing each frame, and we'll see what happens. So I'm now uploading it to the Arduino and uploading, come on. And now we're clearing that frame buffer. This is what we're getting, which is far better. It's flickering on the screen just because of the refresh rate of my phone camera, but yeah, it won't be flickering in real life. So yeah, so we now have our animation walking across the screen. Cool. So what I'm going to do now, just to prove that the y coordinates work, we're going to add a y increment of 3, and we'll so we want to go from so let's say we start at 0 and we'll go to 15. Let's have a look to see how this will look. So let's upload this. So we're gonna move in the X direction and in the Y direction. Let's have a look. So as you can see, the X and the Y planes are totally independent from one another, and in this case the little bird comes onto screen and walks downwards for a tiny little bit. So if you watch, walking downwards there, and then he walks flat. So you can use this if you, I don't know if it's walking on ground or whatever, the ground is different, you can use this in that scenario. So let's do it a little bit more obviously. So let's change it from 15, so let's change it from -1. Ooh. See, with this stuff, it's never obvious how it's going to end up looking. So let's upload that. So we're just uploading it to the Arduino. It's uploading. It's now uploaded, so look, it's moving in both the X direction and the Y direction. And it's looping through. So when the end X position and end Y position is reached, the animation starts playing from the start. All the code from this tutorial can be downloaded from leap.uk, where this tutorial is written up there with more code explanations. You can also go to my GitHub page to download the code, which is all linked into leap.uk anyway. So next we're going to take this code and we're going to turn it into a class. And the reason to do that is this code is good if you're just drawing stuff on screen and you're not doing anything else. However, whenever we're drawing the animation on screen, we've blocked our code. So this is a blocking. So I'm going to write here blocking function. So this is what we call a blocking function. So while this is happening, our microcontroller can't do anything else. So while this is being played, we can't do anything else. Okay, and that could be problematic for many different reasons. So if you've got buttons, so if you need to react to user input, so you've got buttons or you've got sensory information and stuff, your microcontroller won't be very responsive because it'd be playing an animation and it'd be just playing the animation. That's all it would be doing. So what we're going to do is we're going to take all this code and we're going to stick it in a class. We're going to stick it in a class, and once this code is in a class, we can use object-oriented principles to then create instances of that class, and we'll change the code a little bit so it's non-blocking. So we're going to create a class with a non-blocking function to do exactly the same as what we've just done. So I hope you enjoyed this tutorial, and I hope to see you at the next one.